My name is Mirco Dotta. I'm a software engineer at Lightbend, the company that was formerly known as TypeSafe. And today I'm going to talk about Lightbend Lagom, which is an open source framework for writing reactive microservices on the JVM. So you may be wondering what Lagom means and why did we pick Lagom in the first place. So Lagom is a Swedish word meaning adequate, sufficient, just right. And the reason why we picked this name is because often in discussions, in articles, people get really focused on the micro part of the microservices name. And we really think that's not what microservices is about. It's not the essence of microservices. You should really be focusing on right-size services. You should be looking for finding the boundary requirements of your services, isolating what has to be isolated, and separating what you don't need to know within a service. So you should really be focusing on writing Lagom size services. Here is the agenda of the talk. I'll start by telling you why we created Lagom, what are the principles behind it, and then we'll dive into the three main components of Lagom: the development environment, the service API, and the persistence API. And last but not least, we'll discuss how to run Lagom services in production. Lagom is opinionated. So we want you to find an easy and consistent way for building reactive microservices. In fact, when you build Lagom services, they will all look fairly similar one to another. The main difference being the domain that each service is going to tackle. So that actually simplifies you as a developer to move between teams, between different services, because you'll find structures that look pretty similar one to the other. Lagom is built on top of Play and Akka, so it's asynchronous and non-blocking in its core. And we're advocating for event sourcing and CQRS. The reason is that we feel it's a really good and nice pattern for microservices. It really fits in. It doesn't mean that you need to write, you need to use event sourcing in your, if you're writing Lagom services, but we think you should think about it. You should consider that architectural pattern, and you should see the benefits that it can lend you. And I'll talk a lot more about this during the talk. Another important principle of Lagom is that it puts you, the developer, at the center of the whole experience. I don't think there is any other microservice framework at the moment that does that. So if you're familiar with Play, it really has a similar feeling in the sense that with a single task, you can run all your services within a single JVM, and it gives you hot reload. So whenever you do a change in your code, it actually reloads the service for you without you having to do anything. So you're actually always focusing on the task at end, and you let the development environment take care of the rest. So there is no script that you'll have to create in order to know how to run your services. There is no script that you need to maintain across different machines, possibly because your colleagues are using Windows and you're using Mac. You don't have to do that. We actually took care of that for you. Inter-service communication is built in. It's not something that you'll have to think about, and we'll see how it works. And it takes you through to production deployment as well. So again, we really want to get you covered not just during development, but throughout the whole experience and life cycle of your system and application development. So under the hood, I already mentioned some of its components. It's built with SBT. In fact, the development environment is built as an SBT plugin. It uses Play and Akka 2.4. The components of Akka 2.4 that we use, it's cluster streams and the persistence module. Cassandra is the default data store. I'm going to emphasize that even though it's the default data store, it doesn't mean that you have to use Cassandra. But we're opinionated. We had to pick something. We think that Cassandra is actually a really good fit for producing reactive services, because it has good scalability and good resiliency guarantees. So that's what we integrated. It is also possible to run it within the JVM. So we embedded one. We embedded Cassandra in the development environment, again, to simplify this get this started experience, but you're free to use something else. JSON is used for JSON serialization. We'll see that JSON is the default serialization format in Lagom. Juice, dependency injection framework. And we have some architecture concept in Lagom, so immutability. And the reason for immutability is because you get thread safety for free, so you can really scale up. Event sourcing and CQRS, as already mentioned, and I'll be talking about this later on. And circuit breakers, which are built in every service. So you don't have to do anything. It's something that is already built in Lagom. All right, enough slides. It's time for a demo. And I'm going to show you the development experience that you'll have by writing Lagom services. So we have a sample application. It's a Twitter-like, extremely simple application. It's called Chirper. It's an SBT project. So I'll just type SBT. I'll enter into the SBT console. At the end, you'll have all links to go and fetch the code and try things on your own. So you don't have to, you don't have to really know where these things are at the moment. And the one task that you need to run is run all. This is going to start the embedded Cassandra server, which is used for persisting information for your microservices. Then we start a service locator and a service gateway. The service locator allows services to discover each other and communicate. And the service gateway gives you an easy way for querying your different services, because every service is going to be starting on a different port. So you don't want to remember on what port each service is started. You use the service gateway as a proxy to access your different services. And then we have a sequence of services. As you can see, Chirper is made up of a few services that is they're also started for you. One thing I want to emphasize is that these services are started on, you can see they're started like on some ports. These ports are actually assigned consistently. So if I'm running Chirper and one of my colleagues is running Chirper, the same port is going to be used on both machines, which is actually a benefit because it allows you to have scripts for like loading maybe taste data or things like that you can share across your teams. So let's just quickly see if it works. So this is the Chirper app, really simple. You can follow people, and you can just tweet or chirp, and it will appear on your stream. And that's really what you get. And now I'm going to show you that I'll be doing some modification in the code and what happens in the development environment. So let's say that I'm going to add a print line. I'm just going to log something. And let's go back. As you can see, the development environment picked up the change, and it's already recompiling that service. It's reloaded. And now, if I'm going back and tweet again, hello, let's see. Where did I make the change? Oh, get live chirps. OK, I'm going to reload this, and hopefully, we'll see the message there. So everything happened for you underneath. You could just focus on writing your code, focusing on your domain, and the development environment takes care of the rest. So I'll stop and get back to the slide. So the anatomy of a Lagom project, it's an SBT build. You're going to be using Scala 2.11 and JDK 8. And for each service definition in your build, you'll have two different projects. So each service, you create two SBT projects. One is an API project. The other one is the implementation project. The implementation project implements the API. And we'll see what it means in practice in the code. So let's have a look at the service API. How do we define our services? We create a trait, hello service. So we're going to create an hello world microservice. I know that talking about hello world is usually very trivial. It's a trivial example, but you'll see that actually this hello world services is quite representative of how you're going to create your own services. At the end of the day, you'll be exposing some endpoints, and you'll be doing something in reaction to calls to your endpoints. So they're all going to look very similar to this trivial example. So we define this trait, a hello service, that extends the Lagom service interface. And we're going to have to implement one method, the descriptor method. Descriptor is just a set of endpoints coupled with metadata about how the service calls are to be served. So in this case, we're providing a name for our service. The name is going to be useful for services to communicate between each other. In fact, if you remember before what I showed you in the development environment, when the services are started, they're actually registering themselves to the service locator, which is also started for you in development. And what they're going to register is their name together with the URL on which you can find them. And then we have an endpoint that we exposed, this at a static path, hello. And on the right-hand side, we have the action that should be triggered when that path is going to be called. So it's all very similar to, well, if you're familiar with play, it should look fairly similar. And the underscore after the say hello method is just a syntactic thingy for lifting a method into a function object. That's all it is. And then we have this abstract method, say hello, that is going to return something that is of type service call. We're going to talk about service call in the next slide. And this is the only source, in this case, that we're going to place in our API project. This is it. So let's look at service call, what it is. So service call is just a trait that takes a request and returns a response in the future. So it's asynchronous, that's all it means. So you can really see that as a function that takes a request and returns something. So request is the type of the incoming messages. It can be really any type, for instance, string, but it could be your own types. And response, again, is any type. Again, in our previous example, it was a string, but it could be a model class that you define. JSON, as I mentioned at the beginning of the slides, is the default serialization format. Of course, you can plug something different if you need to, but we're opinionated, so that's the default. And there are two kinds of request and response messages. We have strict request and response messages. That is actually what we've been seeing before. Those are strict, string in that case is a strict message, and we have streamed. So let's see what is the difference between these two kind of messages. So in this case, it's a strict message. Friend ID and not used are strict messages. Not used, it's only expressing the fact that the response is not something that we need. We're not interested in the response. It's like saying it's void, it's unit. And one thing I would also like to mention is that before we were using named call for creating the endpoint. Now we're using path call. So what is the difference between these two kind of calls? So in the case of named, it was a static path. In the case of path call, it's a dynamic path. In fact, we're extracting something from the path, and we're passing it to the add friend method. So friend ID, not used, those are strict messages, and that means that they're fully buffered in memory. Let's say we want to do streaming. Because, well, let's say that we have a sequence of elements that we want to send or receive from another service. You don't want to buffer everything in memory, right? So in that case, you should be using streaming. And how do we use streaming? Well, we declare the request or response to be a source of something. If you're familiar with AcaStream, that is an AcaStream source. And what we get is actually back-pressured asynchronous streaming across our services. Source, if before our messages were the transport protocol was going to be HTTP, at this point in time in Lagom, the default transport protocol is HTTP. We're going to add other things in the future. If you're declaring your response or request messages to be a source, that will be mapped into a WebSocket at the moment. All right, so remember our service definition. Let's see what the implementation of this service looks like. Very simple. We have a class, service implementation. It extends our trait. And we need to provide an implementation of the sayHello method. And what that implementation does is simply returning a feature of a string. That's really what it is. And this source file is going to be placed into your implementation project. So the implementation project, since I need to extend the hello service trait, it has to depend on the API project. Now, let's say that I have another service, and I want this service, this new service, to communicate with our hello world service. How can I do that? That's actually extremely simple. I simply need to inject the hello service interface or trait into my implementation class, and then anywhere, so in this case, in the implementation of our sayHello Lagom method, I'm going to invoke the service, the hello service endpoint. So really, really simple. Good. So the persistent, so what I show you is how to write stateless services, right? But at some point, you will want to persist information in your services. And this is where the persistence API will be handy. So let's explore the persistence API. There are a couple of principles. One is each service must own its data. So only the service has access to its database. Any other service that is interested in the data that is owned by one service, it should ask for information, but it does never have access to the database that is owned by the specific service. And we advocate the use of event sourcing and CQRS. Not sure whether you're familiar or not with the concept, but at a very high level, event sourcing is about capturing all state changes in your applications as events. So if you compare that to a CRUD data store, it means that, so with CRUD, what you know is that you always know the current state, but you have no idea how did you get there. You don't know that. You can only know about what is the state today at this point in time, but you don't know how you got there. With event sourcing, you're actually capturing the events, so the facts that actually made your state evolve throughout the life of your application. So since you're all familiar with functional programming, you could see the current state as a left fold of the events that you had in your system. And CQRS is a pattern that basically tells you that it's interesting or it's a good idea to separate the models for write and read so that you can scale both and you can tune both accordingly because you have different needs when you read data and when you write data. There are a couple of things that I want to point out before we get into the API because it often gets people confused. In Lagom, you don't have to do event sourcing and CQRS. It's something we're advocating, but it doesn't mean that it's the only way. We're using Cassandra, so the persistence API is tightly coupled with Cassandra. If you don't want to use Cassandra, you're simply not going to use the persistence module of Lagom. You'll use something different. And if you don't want to do event sourcing and CQRS, but you still want to use Cassandra, you can still use the persistence API, but you're not going to use the abstraction that we created for doing event sourcing and CQRS. So some of the benefits of event sourcing and CQRS. It allows you to time travel. Why? Well, because you have events are what determine the state of your application. Since you're storing all the events, you can just go back in time and replay the events up to that moment to see what was the state of your application. You get an audit log for free. And it opens up for future business opportunities because you are recording everything. You're not losing any information, right? So let's say that there is one of your business persons coming to you and say, well, I'd really like to implement this new use case. Can we do it? You can say yes. You can actually benefit from having stored everything about your application and use those data so that in a useful way. There is no need for an ORM. There is no need for that because there is no impedance mismatch. The events, which is what define your state transition, is actually what you store. There is no migration script ever that you need to create. And the reason for that is because your tables, your read tables, the query tables, you can recreate them starting from the events again. The events are the only single source of truth. And everything else can be recreated based on the events that you stored. And you will never delete events. And there are good and interesting things related to performance and scalability, again, because you can have different databases, for instance, for writes and reads, that are tuned for the specific needs that you have. And they're usually very easy to test and debug, even-sourced systems, because you can send commands that generate events, and those are the things that actually generate state transition in your application. So it's very easy to reproduce a problem because you can just go in the log, you see what were the commands that were sent to my application, and you reproduce those in your test, and your application will be exactly in the same state. So let's see how it works, event sourcing in Lagom. So you'll have to create command and event classes. I didn't mention this yet, but command are things you'd like the system to do. Events are things that the system has done. They're facts, things that already happened. So when you send a command, it may trigger an event, or it may not. It depends. If the system is OK in handling that command, there is going to be an event that is generated out of that command. But a system can also reject a command, and so there will be no event generated. And so after creating your command and event classes that are just Scala objects, Scala classes, case classes in the specific case, you'll have to subclass persistent entity. So persistent entity, it will just define command and event handlers and state transition. So the persistent entity is going to represent the state of your entity. We'll see what an entity is with a specific example. And you'll send command to this persistent entity. Command will generate events, so we'll store events. And events means that we're also going to transition the state because the persistent entity represents the current state of your application in memory, right? And events are things that you're going to store in your database. And if you're familiar with DDD, a persistent entity is an aggregate root. So let's implement the add friend functionality of our Twitter-like application that I showcased before. We're going to define friend commands, a trait, and add friend is going to be our command that we're going to send to the persistent entity. So we want to add a friend with a specific user ID to a user. Let's create the event that will be triggered if the command is accepted by the system. So events are facts, are things that have happened, and that's why we call it friend added. Okay, that's a fact. Once the event is produced, it means that it's an accepted fact. And now we implement our persistent entity. So we just extend persistent entity, and we have this initial behavior method that we need to implement. So let's see what we put inside. We have a command handler. So what is the command? Is this add friend, right? So we set a command handler that takes add friend, and it will answer. It will react by, well, let's check the state, the current state of the entity. Let's see if there is a user. If there is no user, then we can add a friend to that user, right? So if the persistent entity state has a user, then we're going to produce an event, friend added, and here it's the response that we're going to send back when the friend command is sent, when the friend command is sent to our persistent entity. And in the case that there is no user, so if there is no user, we can't add a friend, right? And if we can't add a friend, then we can do validation and say, well, we can't accept this command. And this is the case when no events is going to be persisted, because we cannot be adding a friend if we don't have a user in the first place. Then we're also going to create an event handler. So the type is going to be friend added in this case, and the friend added event was produced by our command handler that we've seen before. And what this event handler will do is that it will update the state of, of our friend entity, right? It will update the state by adding the specific friend to the set of friends of our user. Important thing is that there are no side effects that should be done here. And the reason why there should be no side effect done there, let's say that we're talking about like purchase orders. And one side effect could be like, I want to send an email saying that your order has been accepted. You shouldn't be doing it there because in an event sourcing system, you want to be able to recreate the state by replaying the events. So if I'm replaying the events, it means that I would be resending emails to all, for all purchase, which is not something you want to do, right? So that lambda has to be side effect free. And finally, this is the friend state. So this is the current state of our friend entity. And that was the add friend method that we were calling before in the event handler that we have just seen. I'll just go back one slide. You see when we do state.addFriend, this is the state that is managed and held in memory by our friend entity. Good, so we have defined these different commands, events, the friend entity, the friend state. So we got all the different components. Now we want to use this friend entity. How do we do that? Well, in our friend service implementation, we have a method addFriend, right? There is going to be an endpoint for adding a friend, exposed by the service to add a friend. And so what we need to do is we need to inject that persistent entity registry in our implementation class. The first thing we want to do is register the friend entity to this persistent entity registry. And then in the add friend functionality, we want to get a reference to the persistent entity for a specific user ID. So we are going, in our cluster, we're going to have only one instance of a persistent entity for every entity ID, right? You don't want to have more than one, otherwise you get problems about data corruption, right? There is only one truth, and every persistent entity is going to exist only in one node, somewhere in the cluster. It's not up to you to know, it's all handled for you. And what we're going to do is that we're going to send a command, add friend, to our persistent entity, right? And then this, the persistent entity will decide whether it can handle that command and so produce an event or not, as we've seen before in the implementation of the command handler. So that was the write side. Now let's look at the read side. The read side is tightly integrated with Cassandra. So you'll have to use things like the Cassandra query language to extract information from your query table. And how do you create your query table? You need to subclass Cassandra read side processor. That's again a Lagom abstraction. And what you will do in this class, you will be consuming events that are produced by the persistent entity, and you will update your tables. Right? So we're really separating the write side from the read side. There are two different things, and the read side is really a view of the write side. We can always change that view. That's why there is no need for migration script. If tomorrow we want to change the way we want to represent our information, we only go and change the tables in the red view. Our facts, our events, they're not going to change. They're always the same. And so you can really, your view can be really highly optimized for, let's say, the screens, if you're building a web app, or for whatever need, for what you need, for the way you want to consume your information. So, running in production. Lagom supports or integrates with SBT native packager, so you can produce executable, well, you can produce zip, RPM, Docker images, pretty much anything you want. And it is integrated with Lightbend conductor. So by that, it doesn't mean that Lagom knows anything about conductor. It's the other way around. Conductor knows how to run Lagom services. So it's really, really easy to transition from development to production because you don't have to do anything if you're using Lightbend conductor. So Lightbend conductor is actually available for free for development. So I encourage you to try it out and see how it works. It's all for free. If you don't want to use conductor, it's okay. You can use other orchestration tools. We don't have support for that yet. I'll talk a bit about that at the end. But what you need to do is basically only provide an implementation of the service locator interface of Lagom. That's all it's needed. There is documentation for that. And we actually already started a project or a new module for providing integration with Kubernetes. We're not actively working on it. We hope that the community also can help us. But we're definitely not against running Lagom services on other orchestration tool. Actually, it would be quite cool. A couple of things that you get by using Conductor and the Lightbend Reactive platform is that you get monitoring support. So I told you at the beginning that circuit breakers are built into Lagom. And the monitoring that we have actually can show you the state of your circuit breakers. So you can see whether, let's say, a service is being hammered, so it's not ready to handle any other call, any other request. So in that case, you'll see that the circuit breaker is closed. Otherwise, you'll see that it's open. And we're going to be adding, of course, more and more things like you want to see how your futures, we're going to add future support, streaming support, kind of seeing what's happening in each of your services. And split brain resolver is extremely important for handling network partitions, which again, it's something that you want to check when you're going to be running your services in production. It's not related to Lagom. It's really a general thing. What happens if there is network partition in your cluster? And if you're using Lightbend conductor, you actually are okay with that. There are strategies that we have implemented, and this is what split brain resolver is about. It makes sure that in case of a network partition, the cluster will manage how to resolve the problem. If you're not using Lightbend conductor, then you'll have to be aware of this problem and see whether the orchestration tool, the specific orchestration tool you're using, can handle that. So the current version of Lagom is 1.0 and 2. 1.0 final is coming soon. What I showed you before was using Scala with the Java API. In fact, I'd like to hear what you guys think, because I thought it was fairly idiomatic. Like, it would be hard to tell that I was using the Java API. At least that's how I felt. So my point is that you can use Scala today with the Lagom Java API and reaping all the benefits of using Scala. Like case classes, it's huge. Like when I compare the sample application written in Scala and in Java, it's just no question about which one I'd like to maintain. And that is the link to the sample app written in Scala. The Scala API will come. We're working on it. There are, 2 people are working on it, and I'm one of them. So, but I don't think that things will be completely different. Actually, I think they'll be fairly similar at the end. So in the future, this is a list of things we would like to work on. It's not prioritized or anything. It's actually sorted alphabetically. So we're going to add Maven support. This is mostly for, well, I would say this is mainly for our Java user, but I'm sure that many of you also wouldn't mind having Maven support in the enterprise. Message broker integration, which is needed for decoupling your services. Scala API, I already mentioned that. Support for other orchestration tools, I told you about that. Support for writing integration tests. So that's actually something we would like to do. What we would like to do is allow you to write your test and somehow be able to run the run all task in the background so that you can actually test, I guess, the real implementation of your services. And Swagger integration, which would be extremely handy for avoiding binary coupling. So why do I talk about binary coupling? So what happens when I want a service to communicate with another service? Well, at the moment, my service project has to depend on a different service project, right? And what that means is that I'm actually inheriting all the class path of that microservice into my class path. That is not good, because we might be wanting to use different versions of libraries and incompatible versions of libraries, right? So you don't want that. By having Swagger integration, what we're going to be able to do is that you can actually generate this interface basically dynamically, so that there is no coupling. You're going to depend on a specification, and then we'll generate those implementation for you. So you will get no coupling, no binary coupling between your services. So next steps, try Lagom. Gives us feedback. It's definitely a great moment to provide feedback. Using Scala with Lagom, follow that link. It's a GitHub project. Read Jonas' Bonner book. If you don't have it yet, just come to our booth and you can pick a free copy. And there is a really great presentation by Greg Young, who is actually, well, the guy behind event sourcing, about why event sourcing is a great architectural pattern. So I'd encourage you to listen to him if you're interested on the topic. Thanks everyone for your attention. And if you have any questions, I'll be happy to answer them. Right, so the question is about deployment support for Lagom services. And so our orchestration tool, Lightbend Lagom, it is meant for deployment. And what it has lots of features, and things that we're working on is for rolling upgrades, so that you basically never have to turn down the service because you want to bring on a new version of that service. It actually provides you a way for doing that smoothly, so that you have no downtime when upgrading and publishing a new service. So we don't have integration with Amazon. What you should consider having a look at is our orchestration tool, Lightbend Lagom. And if you don't want to use that, as I said, we are thinking of adding support for other orchestration tools, but at the moment that's only really the one that we support. It's a 1.0 M2 as well, so we had to focus on something, and it made sense that the first thing we would support is what we produce. But it's an open source project as well, so we really and truly hope that the community will like what's in there, and we'd be happy and thrilled to see contribution from the community. Right, so the question is about how Swagger integration will avoid binary coupling. So at the moment, we wrote a document about that internally, kind of getting a rough idea of how it's gonna work. But so if you look at how things are at the moment, is you have this service interface where you provide a descriptor, and it's all in code, right? And you're basically describing what are the endpoints, and then you're also adding metadata about how these endpoints are going to be served, right? Well, what we want to do is, instead of describing that in the code, let's describe that using Swagger. And then from that, we can generate the code for you, but you don't have to know. So that services will depend on the Swagger specification, and then on the fly, we can, well, on the fly, like compile time, it doesn't really matter when we do it, as long as you don't have a binary dependency on the thing that we produced. But does that answer?
So how does binary dependency, what's the problem with binary dependency? Is it just the clashes and?
Oh, no, the problem with binary dependency is that, so you have two microservices and one wants to talk to the other. So the problem at the moment is that in order to talk to service B, I need to have in my class path the service B API project. The service B API project may have different things in its class path, right? And one of the principles of microservices is that they should really be decoupled. Like I should be free of doing any change in my microservice because the only communication channel is my endpoints definition, right? That's the only way for you to get access or to get information about what I'm doing. So I shouldn't be leaking implementation details, and binaries are implementation details, and so that's something we shouldn't want to leak. And that's why we're going to be working on Swagger integration. But, you know, it might be, it really also depends on what you're doing. It might be okay within a company to say we're going to standardize on specific version of, let's say, Juice, other than different libraries, and say this is actually the version that we're going to use across all our services. And maybe in that case, you don't need Swagger integration. You can just, you know, it's totally fine to have those binary dependencies because you decided to own and decide what version across all different services you're going to use. So I would say it's an additional feature. It doesn't mean that everyone will have to use that. Thanks again.